The GEO-Academy project and the methodologies behind this Teacher Academy effort. And then I will try just to showcase a few exemplary cases related to geospatial technologies, geospatial activities, and lesson plans for sustainability education. So, in a nutshell about GEO-Academy, the core idea started a decade ago, to be quite honest. We had previous projects and we were trying to integrate, geospatial technologies and geographic information systems into science education and sustainability education. So 10 years ago, we started with GeoThink project, VISTE, for empowering spatial thinking of students with visual impairment, then GoSTEAM, ClickPolit, and many other projects. And we ended up 4 years ago, actually, to form a consortium and prepare the GEO-Academy vision. The project consortium consists of 12 partners from 7 European countries, universities, pedagogical institutes, NGOs and organizations working with sustainability education. The core idea, and let's say our hidden superpowers, were focusing on the unified competencies. How is it possible to talk about sustainability competencies without incorporating the digital competencies and skills, and of course, the spatial skills? Because no matter what we are thinking about, climate change, environmental problems, biodiversity, degradation, etc., every single problem has, let's say, a spatial component, has coordinates. Somewhere is happening. So the idea was, and still is, of course, to unify sustainability, green, digital, and spatial skills. And to do that, we have to, let's say, intertwine, to link geospatial technologies to sustainability education. And it's quite easy. We are doing that for the past 10, 15 years. And here you can see how different geospatial technologies and topics may fit into different sustainable development goals. So satellites and Earth observation, geographic information systems, web, digital platforms, they are all interrelated to different sustainable development goals. And we created the second component of the GEO-Academy project, our geo superpowers, our geo topics. The first geo concept, or geo topic, as we call it, is about geographic information systems. How to process data, to download data, to analyze data. Cartography and thematic mapping, how we can create maps, how we can read maps, and how we can take advantage of maps to communicate information. The third one, remote sensing and Earth observation, quite impressive on the information we may collect using different satellite missions. Of course, geospatial or map storytelling, how students can develop and create their own stories using maps, using audiovisual contexts, and some quite impressive digital platforms. And of course, programming, the last superpower, programming, STEAM, and robotics. And we developed training courses for teachers, but also teaching resources, lesson plans, teacher guidelines on how they can integrate those superpowers into science courses, language courses, environmental education, and geography courses. A few words about the methodology, the unified competencies that we just mentioned, the green competence framework, the digital one, and the spatial skills, and how we unified them to, let's say, a unified list of knowledge and skills on how to embody sustainability values and spatial literacy, system problem solving and critical thinking, using different geospatial challenges, etc., etc. Based on these competencies, we developed the training and teaching resources. Of course, we analyzed the curricula. 7 curricula in Austria, Greece, Cyprus, France, Sweden, Portugal, and Greece, of course. And we tried to allocate space into each one of the national curricula to fit, let's say, our activities, our teaching and training resources. So, for example, here in Greece, we have the skills labs, both in the primary and the secondary schools. In Austria and other countries, we have the environmental or sustainability education programs. And in this way, we created, let's say, multi-level activities, both for the primary and secondary schools. Of course, we have our training model, a model that we used and tested, developed by Klaus, who is here with us today, and the Pedagogical Institute of Tyrol. So we had the training model that we used in all trainings over these 3 years of training activities. It's called Bridge. And why it's called Bridge? Because during the trainings and after the trainings, of course, we are trying to link, to bridge the curriculum to the learning objectives. That's why we have the Unified Competence Framework, the curricula screening analysis that we showed, and then we tailored the training and teaching content. Also, we developed an online platform. It's called GeoObserve, the GeoObserve portal, where we host all the training resources, the geospatial tools we are using. We have different groups, communities, let's say, the national communities for the countries we've mentioned before, the international community, the community for the Eratosthenes experiment, and of course, a community will be created for the upcoming map storytelling competition initiated a few weeks ago. So we have a lot of training and teaching resources. Here you can see the geospatial concepts and the e-modules, as we call them on the GeoObserve platform. It's like lifelong learning courses. It's for free. We have different lessons, and some of them are quite short, 1 hour or 30 minutes or 2 hours. Some others are a bit more, let's say, extended. So our e-modules are focusing on cartography and thematic mapping, GIS, Earth observation, map storytelling, and STEAM. And we have 2 cross-cutting e-modules about the Unified Competence Framework. Maybe it's good if you start from there. And at the end, about assessment practices, tools, approaches, and rubrics you may use to assess your students' competencies and unified competencies. So a few screenshots from the platform. We are trying also through the GeoObserve platform and the trainings and the material we developed to highlight and foster specific pedagogies and concepts like whole school approach or the living labs. That's why during the project we are establishing the GeoLabs, which means different schools across Europe are testing, both teachers and students, the GEO-Academy resources and lesson plans and activities. So some schools are focusing on GIS or Earth observation. Other schools are focusing on robotics, because we also have some Geo kids with different robotics-related activities. So in all countries, we are forming these GeoLabs, developing different projects. And of course, the schools are trying to collaborate, of course, with the partners of the GEO-Academy project, but also with external, let's say, stakeholders to develop their projects and communicate their results. Of course, during the project, we had a lot of training activities. I mean, a lot of training activities, both at local and national level in all countries, as you can see. We had 3 international training activities. The first one in Greece, the second one, a winter school in Austria, and last summer, our last summer school in Portugal. But we still have the final GEO-Academy International Conference, where teachers are going to present their experiences from the GEO-Academy interactions with the GEO-Academy partners and the pilot testing activities. And of course, just to keep in mind, the winner of our map storytelling competition will also join, the teacher will also join to present the students' projects and the students' activities. Just to mention here, if you visit our GEO-Academy website or the GeoObserve portal, you may find more information about the map storytelling competition. It's the first pan-European map storytelling competition. It focuses on sustainable development, and it's called Geo Voices. Many different schools across Europe will participate. The students are going to create their own projects, and the competition just initiated and will end by the end of February. So a few pictures from our summer and winter schools here in Marathon, in Athens, in Vienna, and in Sesimbra in Portugal. More than 60 teachers were trained on the GEO-Academy concepts. So I will start, let's say, bombarding with a few exemplary cases from activities, from concepts and tools, just to have an idea when we are talking about geospatial concepts and geospatial technologies, what is it all about. So we mentioned we have our superpowers, and we start with cartography and thematic mapping. It's quite easy in primary school students to use some quite simplified tools like this one, where the students may compare the continents and the countries' actual size compared to the Mercator maps we have in our classrooms. So when we see the Mercator map, you know, we are trying to project the globe into a two-dimensional space, and some fallacies starting to emerge, because the actual country size, if we see the globe, they're not the same. So close to the equator, the sizes are more or less the same, but in the northern or southern parts of our globe, you see that the actual size of Russia, of the US and Canada, of the Arctic region and Antarctica are quite stretched, are quite smaller. Other activities on thematic mapping, students may learn how to read maps, thematic maps, how to identify patterns, to analyze data. Here we see an exemplary case with the adjusted regional differences for primary and unified school districts in the US, about how much money they spend per student and by school district. So we see these differences in the western part of the US and the east coast of the US, and it's quite really interesting for students. Something more funny, let's say, but still is a map. Here is a map of all shots that Kobe Bryant took during his career, something more than 30,000 shots. And this map shows how many shots he made and how many shots he missed. Of course, in this tool, students may try, different basketball players, and they can start analyzing the basketball court patterns and maps. Still, it's a map. 3D maps or 2.5 dimensional maps or tactile maps. It's quite easy nowadays to print in 3D. Some schools or some, let's say, community centers have 3D printers. We can easily download from the internet, the projects, and just send a 3D project to the 3D printer and then just print it. Also, you may develop tactile maps for people with visual impairment. And that's a really interesting topic on how we can use, let's say, accessibility and inclusiveness in cartography and thematic mapping. Of course, the map storytelling superpower you may find on the internet, and of course in the GEO-Academy courses, different exemplary cases on how to develop your own story maps. about many different topics. Topics related to social sciences, environmental sciences, or even mathematics and natural sciences in general. Here we see an example from for the refugee crisis and how refugees were moving from different countries to the European countries, etc., etc. Also, one of our partners, Spotin, is organizing for the past 3 years national map storytelling competitions here in Greece, and now they are organizing the Pan-European map storytelling competition under GEO-Academy, and you may find different topics here. 3 years ago, the map competition here in Greece was focusing on refugee paths, mapping refugee stories 100 years after 1922. 2 years ago, how to map accessibility, and if our schoolmates in a wheelchair may come to our school, is that possible? Is that easy? Let's map different routes from and to our school. And the last competition last year, it was related to water routes, and the students tried to map the value of water, both metaphorically or, literally. More examples: a new superpower, GIS, Geographic Information Systems, and how we can create 3D surfaces to identify potential landing sites on the Moon and the Mars. All these activities are on the GeoObserve platform. So the students create a 3D model of Mars, they analyze different criteria, and they select the best possible location on Mars to have their rover landed. They can create their own GPS using some GIS platforms, and they can test different scenarios for shortest or fastest paths in their city or their town or their village, let's say, for example. Other examples related to history. Here you can see the example with the ancient tunnel of Eftalinos in Samos, and students explore using topographic data, contour maps actually, how 2,000 years ago to 2,500 actually, I think, how Eftalinos managed to drill one mountain from both sides in order to bring water to the ancient city of Samos. And he used geometry. The theories say that his analysis was based on the Pythagorean theory. The problem is that Pythagoras was born 500 years later after Eftalinos. So that's something quite interesting. We still don't know the answer, but we have the tools, the geospatial tools, to let the students explore these solutions. Of course, here is an example from Austria. The students may download data from meteorological stations, and they can create their own 3D or 2D maps. They can create a map like this. Here we see the temperature for one specific day in Austria. The students downloaded data from the meteorological network of Austria. It's for free. And they can create, using different mathematical schemes, those maps. Of course, renewable energy sources, how the students using printed maps, they can combine different criteria and identify the best possible locations. Here is an example in the Aegean Sea to place wind turbines. Of course, we may apply the same lesson plan, let's say in France, in Portugal, okay, not in Austria, maybe only for onshore wind turbines. So students, and of course teachers who are getting trained, they got familiarized with multi-criteria problems. Of course, we have many GIS platforms, which are made mainly for teachers. First example here, the Map Maker. You don't have to do anything, just visit the Map Maker WebGIS platform, and you may start loading data, analyzing patterns, and start a few debates or discussions with your students about different phenomena. related to climate change, to sustainable development. You may visualize different economic data, etc., etc. Other platforms, GIS and Earth observation, but we will see a lot more about Earth observation during the training. Copernicus browser, and how from your computer in your school you may find satellite images, analyze different satellite images, extract useful information, etc., etc. It's totally for free. Another GIS map, the EMODNet map viewer, everything related to the sea and the seascape. So you may visualize the habitats, the marine habitats, areas where we have corals or seagrasses, different human activities in the sea, and then you can start building your activities and your lesson plans. More platforms. Here we have the platform from the United Nations. Quite easily, you can visualize different phenomena and export those maps, both on PDF or JPEG format. Here we see the global CH4 emissions, but there is a detailed list with 127 different data sources. And related to Earth observation, using these platforms, you may create activities and let your students explore how our world is changing. Here we see the change in Dubai over the past 20 years and how the urban expansion patterns evolved. Another example, you may identify natural disasters. Here is the Etna eruption back in 2017. Or you may find the devastating changes in the Aral Sea between 2019 and 2025. Of course, the changes in the Aral Sea were even more destructive during the past 30 years. All these are satellite images that we found via the Copernicus browser. Nature-based solutions and Earth observation, and how we can make our cities more green, let's say, by taking advantage of nature-based solutions. We have a lesson plan on the GeoObserve platform dedicated to Earth observation and nature-based solution, project-based activities or challenge-based activities, coding, and you can use Python scripts. Only 10 lines of code in order to visualize different scenarios related to sea level rise. So with 10 lines of code, your students may explore what is going to happen to an area. Here is in Greece, if the sea rises up to 10 meters, 25 or 50 meters. Okay, 25 and 50, it's impossible. It's a biblical disaster, but you know, it's more fancy and more impressive for students. I mean, the images. Coding, earthquakes, and here's an example in one of our activities about Santorini. Last year, we have activities and lesson plans related to coding and earthquakes, robotics and light pollution, how they can develop, the students, they can develop their own projects on how to reduce light pollution in an area. And that was it. It was a lot of information, yes, but you know, we are trying, and we try to show you every single application or potential application and fit of geospatial technologies and the GeoObserve resources actually to your school activities. A few key takeaways. Spatial, green, and digital skills matter, and they are interrelated. It's good if we don't solely focus on how our students are going to develop just green skills or just digital or just spatial. We have activities and we have the manners, let's say, and the way to develop activities that are fostering unified competencies both for students and teachers. You may use and combine different geo concepts, different geo superpowers, as we mentioned. Also, we have many different geospatial tools you may take advantage of. And of course, please feel free to join the GeoObserve platform and the communities to explore the training and the teaching material and benefit from the resources. And eventually, you will become a spatial thinker, not only you, but most importantly, your students. Thank you very, very much for listening. Maybe we have a couple of minutes, I don't know, Sana, for a few questions. If there are.
And now I'm going to de-accelerate a little bit and go a slower path, a little bit relaxed, and go into some details. So to see some best practices. So I'm going to show you some examples how you can use it in your lessons actually at the school. So maybe I share as well my presentation, and sometimes I have to jump out of this presentation to a web browser. And yeah, I hope you can follow with the jumping back and forth. So let's see, let's share my screen and check if you see everything. Now you should see the presentation. Yes. Yeah, thanks for the feedback. See, yeah. So I named it Strengthening Students' Spatial and Digital and Green Skills. So maybe we start, as Lucas mentioned before, one of our geo topics is geo storytelling or map storytelling, as we named it. It's the map storytelling. And so maybe I start with a short story. Today I had quite a hard time to arrive at my office because here in Austria, where I live in Innsbruck, if you can check the coordinates with your browser in a few seconds. So if you jump to, let's say, Google Maps or something like this, you find my location at the moment. It's in Austria, Innsbruck. And we have a lot of snow outside, so I'm looking outside and I had a hard time to arrive in the office. And even you can check for the amount of snow, the real time amount of snow. You find a lot of information out there. So as Lucas mentioned before, for everything we have these coordinates. In my case, it's Austria, Innsbruck. And you can find the situation as it is now. I'm looking out of the window, and I guess it's maybe now. It's hard to guess actually, but maybe yeah, more than 10 centimeters of snow outside here on the road actually, but up in the mountains. Where if you are going to skiing here in Austria and during the winter season, yeah, there's probably quite more. There's maybe a half a meter or something like this. But you can check the situation if you know the coordinates. So that's a short story. And often in schools, it's a very good idea to start with a story, because humans are very sensitive to stories. So they are binding those stories. If you make this as a beginning, as I did here with my story and the snow in Austria, maybe you can you win them in a topic, or bring them in a topic on geospatial data maybe. So let's see some examples now. That was the competition idea when map storytelling, but let's go into some details now. So what you will see is a collection actually. It's not as Lucas has shown you. There's quite a lot of stuff out there on our portal. I give you the address later on, but a selection of this offer I will show you here today. So I take you to a tour, not that fast, but it gives you a rough overview what we can show you on the portal. And if you are interested in pursuing a topic further, go into some details, or if you missed something here today, you have to go to our website and to gain access to every e-model, these self-paced learning models, the lifelong learning lessons, as Lucas mentioned it before. You find it on the websites, but you have to register. It's only your name and that's it, and the name of the school. But it's an easy task. And then you have the access to an extensive range of resources. So now we need actually the address. It's I thought it's here in the presentation, but I can give you it in a minute. You find a lot of e-learning modules, and the website. Now it's here, yeah. So here it is, the website, the main websites. Actually, there are two websites. One for the promotional stuff, but here's the real e-modules stuff for teachers and for teacher training. It's here. There are all the resources and tools. You can find it on this site, portal.geoacademy.eu. There is everything we collected or created, actually.
May I add something, Klaus? Apologies.
Please.
If we can post the GeoObserve portal link here on chat, because it seems to be inactivate, for me at least.
Yeah.
The website, I mean, Sana, if you can do that, it will be really helpful for the participants. Sorry, Klaus.
Yeah.
That would be nice. Yeah. I see it's active here on this presentation. I can give you the presentation afterwards. It's easy to share, and I show you where you can find it on the internet. Okay, fine. So now, of course I nearly forgot. Every time you visit, or if you are interested in this, if you visit the portal GeoAcademy, of course you can change the language. So that's why I added this screen here. So in the lower part on the right side, you see that you can change the language. So it's here in French, and now I can't read anything. That's the problem. Resources. I realize resources and groups, it's quite the same, but otherwise it's a little bit complicated for me now. So I'm going on in English. It's easier for me. Bienvenue. It's maybe hello, I guess. So let's gain access, full access. You have to log in. I'm actually logged into the portal, so it's my account. That's easy. But the main parts I will show you. So you have to do this login to register for the first time. If you are here for the first time, you have to register your name and your school. That's all. And then you are inside this universe. It's the big universe, the big GEO-Academy universe. The resources and tools bars is open for all. So even if you haven't registered, you can get access to these resources and tools every time. And there are a lot of resources, really. And all the resources are ordered, so you can search for the age group you are interested. If there's a primary school or if you're secondary school, you can do this the search accordingly. That's or the subjects or the topics you are interested. And then here the e-models modules you have to register for to see the whole courses. And from here it goes on to the groups in the middle part here, and we have for all the participating countries group, and also for the France. So that's the Geo Hub here, and you can join the group. So that's on the Geo portal. And now I introduce you to one of the groups. It's not only the country groups. Here we have one group. It's called the Dosterness experiment, because I think it's a good starting point, because the GEO-Academy, actually, it's in the name. The Geo means Earth, and Earth, it's the measuring of Earth, geometry. And Eratosthenes first has an estimate, maybe not the first, but he has an estimate on the circumference of the Earth, the radius of the Earth. And if you are interested in this, I'll show you. At first, you have to join a group. You can join the group. Otherwise, I will show you some details on this as well here on this experiment. The question is, how can you measure actually the circumference of the Earth? And that's the question Eratosthenes put on himself actually. And here we have a nice picture of the contest actually, because the main part or the main idea is you have to have the coordinates of two locations on the Earth. And here it's important to have groups because you are in one location. Let's say in my case, it's Austria, but I need a partner school somewhere north at a different latitude. That would be important. If I find a partner school, then I can make it quite easy to do the calculations. I have a copy here. That's the original scene actually in Siena and Alexandria. And then if you have a difference in the latitude, you can measure actually, if you have you can't measure the radius, of course, but you can measure the length of the shadow. If you have a stick on the Earth and you measure the length of the shadow of the stick, then we have these different locations on Earth with two groups, it's possible. Then you can actually find out how big the radius of the Earth is. So that's a nice experiment, and for this you need some other groups, and in our group, then another Eratosthenes group, you can find a partner school that's quite good organized. So we have these groups, and our platform says we have this community. It's a very important part here for this experiment for sure. Otherwise, it's if you don't have a partner school somewhere at a different latitude, it would be difficult to replicate the experiment of Eratosthenes. So the next stop, that's only an intro, but now our next stop is to have some e-models especially on Earth observation and remote sensing, and in some details. But here you see an overview. As Lukat mentioned them already, you see the map storytelling on the left side, the lower left side, as well on the right side, the coding, and all this. In this course system, there's a lot to find for lessons and lesson plans and ideas. So we check out some ideas in details, and we enter actually these Earth observation, remote sensing, and satellite applications. Now, it's here on the screenshot. And as Shana already introduced to our topic today, it's CodeUp. So you can find this CodeUp resource actually on our website, the link to the CodeUp website, the common online data analysis platform. If you go to the resources, then there you have a short description what you can do with this. But we will do it ourselves. I'm going to the CodeUp, and I'm leaving the presentation mode, and then I'm doing the work in the real time here on this training. So in a few minutes, but you can find it here. So it's important for me that I know you can find everything I'm talking about. So the main part is the portal, and then here in this case you go to the resources, and below the resources you find a lot, maybe also the world forest maps, but I'm the training focus at least in one part on the CodeUp tool and how to use it. Okay, so here that's a screenshot actually of the CodeUp website if you visit them, and then we can with as the name says it, you can track actually the coordinates in an easy way. Let's say here from maybe, I don't know what it is actually, but maybe animals on their way outside the coast. Maybe it's whales or something like this. I'm not familiar with this example here on the website on the present, but I will show you how you can do it on yourself. But first, I'm showing you an overview. So I'm not clicking at anything. I'm doing it later on. But now I show you an overview, and afterwards I'm going to the real stuff, to the code up, and do the clicking and yeah, and everything. But I thought it is better to show you an overview in the first run. So that's the name. It's a common online data analysis platform, and as the name says it, you analyze data, spatial data, mostly spatial. It's not necessary. Actually, you can analyze any data, but in our case, it's mostly spatial data, so you have coordinates in them as well, but it's not necessary. I guess I have an example where it is not necessary. Yeah, the data, if I'm interested in the temperature during a year here in Austria, for an example, yeah, you guess it, right? There's a difference between summer temperatures and winter temperatures, yeah. And now it's only one location, maybe here not in Innsbruck. So the data are over the time. So it's not over the place, over spatial data, so different places. It's on a time scale. So you can analyze this as well. So it's not necessary to have spatial data. Okay, let's see. And I made a story out of this actually. Yeah, and let's say you are interested in this question, the question I will pose to you. How does, let's say, a fire nearby affect the air quality? And even worse, let's say the fire is quite a long time ago, was quite a long time ago. Let's say it was in 2003. That would be hard to find out how this event has, this event has an impact on the air quality. But as all these satellite data, they are stored there out in the web. They are kept there for a long, long time. So you have access to the data actually, and I show you how. And if you have access to the data, you can go back to this year, check your data, import the data to the tools, in this case, the CodeUp website. Actually, it's also, you don't have to install anything on your computer. You can do it live. So you have to import the data. You are interested in some location. I'm going to some location, check the data for the time you are interested in. And in this case, I'm interested in the air pollution data, and I will show you how you can do it. So the question, and normally students are if you put a question at the beginning of your lessons, that's important because the interest, it fires the interest. So if I ask them, how does this fire, make an impact on the air quality? That's a good starting point, a very strong starting point. So a forest fire close at home, what's the impact? That's a good starting point for a lesson and also for a story. And here, in my example, I'm going back to 2020, in July. It was actually, that's a real case, yeah. It's the Bighorn wildfire in Arizona, West. And I will check out the data, and then I'm going to analyze it. And I will show you here how you can do it yourself. It's not that complicated. That's the fun part, actually, because students can do it. Yeah, maybe you guess it's quite complicated, but I can show you it's not. So maybe we have first a look on the situation on a map and on the fire map. So maybe I'm leaving the presentation at the moment and check out this fire maps. So let's see where it is. It's also actually this website. If you are looking for this firm's website, you can find it also below the resources and tools on our portal. Again, so there's not only this code up and other stuff. You find under resources and tools this firm's website, and there's also the link there. So it's all summarized at one point. That's very strong. But here, in my case, I made a link to this fire map, and we are going to visit actually this website. I have, and I'm looking for this fire, Arizona, so I have to remember it. Maybe I make a note here on my on this side. It's 2020 in July. And it's Tucson in Arizona. So I have the coordinates actually. It's the names, but I'm interested in this position and this time. Okay, let's check how you can do it. That's the live demo. Yeah. Now I'm entering the live demo. Great. And I'm jump into this link. You can find the link at the resources and tool part. And if everything goes well, I open the link and you will follow me with the browser. It's now loading the firm's maps. Maybe it takes a couple of minutes. Loading the actual situation on fire, the fire situation as it is today. So, and now you see that's the situation today. Let's wait a couple of minutes longer because I don't see any fire at the moment. Now they are arriving, yeah. And you see, it's that's the fires gathered for all the last 24 hours. So if you are interested in a longer period, you have to go to the 7 day. Yeah. I hope you see where my mouse is moving. It's on the right part, 7 days. And there's quite a lot of fires here. If I go back to 24 or even today, you can change this. But we are not interested in today, 24 hours or 7 days summary file or visualization. We are interested in a specific date. So I'm going to this calendar here. Let's check. And I'm going back, as I mentioned before, the year should change to the year 2020. Oops, that's it. And maybe I have to change the month as well. Let's say June or July, something like this. Okay, that's in the past, and now I have to change my focus actually on the right location. So I'm going here in the lower part. You see it highlighted locations, and then I search. It's nothing different as Google Maps actually. To Tucson, Arizona. Tucson, oh, here it is. That's great. Tucson, Arizona, USA. That's the right spot. Yeah, and now I'm there. Nice, but no fire. You can't see any fire here. The point is we are too near on the city actually. It's up more in the north. I remember because I visited before to check out if everything works. So to be honest, so I checked it. So I'm too near, so I have to focus out a little bit. Let's see. Oops, that's a little fast, but let's see. Somewhere in the mountain regions up there, it should be a fire. Maybe I have made a mistake with the date. Actually, it's here in the mountains. So oh yeah, the date is wrong. You see it here. It's no fire today. So I have to check again. The date is wrong. Let's see here below. I have to move my windows a little bit through because now I'm blocked here. So let's see, check the date again. Oh, my windows. There are a lot of windows here. So now the date is wrong. Let's say go back to 2020, the month is wrong, so check the months right. Maybe I have to go here. October, September, August, July, better, and let's say 15. Yeah, now you see the fire, actually here in the mountains. There are 2 red dots. But how could this fire have an impact on the city nearby? If you change the days, maybe it spreads a little bit. Let's see, yeah, it's smaller now. Maybe it was quite for a long period, so you have to change a few days, but it doesn't matter actually. Maybe it started later on. I have to wait actually, yeah. But you find, if you are aware of a fire, you can find it here on this map because these are satellite data. They are very accurate, and they are monitored by more than 3 satellites, as it is mentioned here, the Landsat, the VIRS, and the MODIS satellite. And now we had found actually the fire, but we have no idea how we can check for the air quality. For this, we have to go to a different data repository to check the data. So I'm jumping back to my presentation. So I'm leaving this firm's website, the NASA firm's website, to check where the fires are. And now, yeah, back in my presentation. And here's the point I mentioned before. We found the fire, but what about the air quality? Yeah. For the air quality, I have to check the data, and again, the data were collected by a satellite. That's the important stuff here. It's actually the Terra satellite, and the data are made accessible in the website from NASA data. And there are a lot of data. It's amazing, actually, how big this data repository is. Let's have a few. So again, you find the website on our GEO-Academy. You're sure yeah. Now, meanwhile, you think everything is there. Yeah, and it is actually. We have this link to the My NASA data on our website as well, under the resources and tool parts, so you can access, and also information about the Terra satellite as well, as you can see it here. And if you visit the website, you have an impression what it is. The My NASA data, you have data on the atmosphere. I'm interested today on the atmosphere because all these particles, these pollution particles from the fire are in the atmosphere. So I'm looking for data in the atmosphere. But you can find data for the hydrosphere or even the geosphere, ice, and so on, even there as well. The water, the geosphere, biosphere, yeah, it's all there. It's a really amazing website, this My NASA data website. So, and from there, I can get the data I'm interested, the atmosphere data. Especially for this state, actually, for 2020 in Arizona, because the Terra satellite was there. So, and now we have to know a little bit. You have to know what's the name of the data that you are looking for. In this case, it's the aerosol optical depth. It's actually how much stuff is in the air, probably. Yeah. Here's a more accurate description of the aerosol optical depth. It's a value calculated via satellite measurements of the aerosols. So it's also the smoke particles in there. But if there's a desert nearby, so it could also be desert dust as well. Yeah, all these particles are distributed in a column of air above the surface. And I have a picture here, so you have an idea how it is done. So the sunlight from above here, an arrow in yellow, and on the bottom you see the ground. Yeah, And if there's a lot of scattering, the light goes away because there are a lot of particles in the air, then you have, then the measured value at yours, or the back reflected value to be measured on the satellite would be different. That's the main idea. The light reaching actually the Earth is different. If there are a lot of particles, as it is in the right side, then the light reaching the surface of the Earth is smaller, and you have a different value for the optical depth. That's all. Actually, you have to know. So you have actually to download the data and collect the data. And maybe I'm going to do this because I have prepared it and here so that we can work with this data, and you can do it as well. So I give you the presentation, then you can have this data set as well. So let's check out, open the link. Maybe it's only a download. Yeah, on my computer, it's now a file. Actually, it's called the comma separated values. It's something like an Excel file, if you are familiar with the Microsoft part. It's quite the same. And then I have this data. And with this data, I'm going to the CodeUp website and import the data. So that's the idea. So you have to gather the data from a data repository. And if you open this CodeUp website, as I'm doing in a minute or in a couple of minutes, you have the first thing you have to remember if you are doing it for yourself is to launch CodeUp. It's up there on the right side, launch CodeUp. You have to read everything here on the website. You can go directly to this launch CodeUp, and then it opens this analyzing stuff. And the first thing, as in a normal Word document, let's say it's that easy actually, you have to create a new document. It's written here, create new document. Okay, we will do it actually. We will do it in real time. But first I show you through all the main parts you have to do to follow. And then the next part is to import the data for sure. So there's a drop-down menu, so it's easy for students as well in our class. In the top left, and you have to import the data, or you can even create your data set for yourself. You can open an empty Excel sheet and put in some data. Let's say you ask ChatGPT about some data you are interested, and then you put this data in a table, in an Excel sheet, actually, Excel sheet. Then it works as well. Maybe I can show you afterwards. So then you select the data you have. In this case, I have downloaded the data, so I have to go there where my download folder is, and it opens. Actually, it's quite that easy. As you see, it's a table. Actually, it's the columns and some rows, and there are the data I'm interested. So this optical depth here in Arizona, and the date is right, 2020. It's in August. Yeah, it's in August. That's the data I collected before from the website, my NASA data. Okay, and then you have to visualize it. Otherwise, it would be hard to guess what it means, actually. So the power of this tool is to visualize your data, to analyze it. And it's that easy. You have only to click at some points. In this case, you have to click on the graph, and immediately you have all the data points, but it's quite, let's say, noisy. Yeah, it's not, there's no order at the moment. There are somewhere these data points. We have collected 80 data points, but they are somewhere quite disturbing actually. But you can bring in the order now. It's easy, drag and drop, and you have to order. With a drag and drop, if I'm interested in the distribution of my data, I have to drag and drop the month. So I go to this column months here in the first round and drag it to the graph here. I do it in a minute. Drag it here down, And then you see, okay, we have some data in August, measurements data, then we have some data for July, and we have some data for June. But it's not clear, there's nothing clear about the air quality at the moment. So let's see a little further. But if I'm going to drag and with the mouse, drag this aerosol parameter down to my graph, as I did here, you see the distribution for this as well. So you see mostly the aerosol parameter is around 0.05, and that says actually good air quality. But there are few measurements outside this range. But I don't know when it happened. So let's check out if I can do this as well. And yes, you can push or drag and drop actually 2 parameters to your graph. You go to aerosol and put it on this vertical axis. And then I go back to the table and drag my date here. And then you see over the time, there's a difference in the air quality. At the end, you see it's rising. Oh, let's see if I can make the picture a little bit better. Yeah, you see it here. In the end, at the end of August, it's rising. So that's easy actually to work with them. And to convince you, I have to go to the website as well and do a live demo. Maybe you are convinced even more, huh? Now it is here. It's time for the live demo. Okay, so yeah, let's check it out. So I have to open a new window here. Let's see, or maybe we go back to this NASA's firm's website, and I change for CodeUp website. So now I'm here at the CodeUp website. You see it in this live modus. Yeah, some advertising, some stuff there, but it's for sure it's free. Yeah, that's important for all our tools. It's a very important feature, because for schools it's important that they are free, the tools. So, okay, we have this code up here now, and now I have to move this windows with all the yeah from the Teams session a little bit below, so I can reach the launch button. And now I'm going to launch this code up. So as I mentioned before in my presentation, that's the first thing you do, to launch code up. And I will do it now. Yes. So and then you see it as it was in my presentation, it changes. And yeah, oh, it's blocked. No, it's not blocked. It's an ad block from my from my computer because I don't like the ads. No, it was an ad blocker. So, but now I'm back to the document. I made a mistake. I closed the microphone because the microphone came into the way to change my browser field. So let's see if I can stick it at some other point, this window, because it blocks my navigation part. So let's see. Yeah, now it's I have to move everything, the windows on my screen, a little bit further away. So it's easy. I'm back. Okay, you should see at least the CodeUp website, the empty CodeUp website. And as before, as we mentioned, you have to create a new document. Okay. Then I'm going here on this left side and import the data I've downloaded from my NASA data. And I have a local file, so I have to click here or to track it. And here that's the NASA data I have downloaded. You see it's today. It's actually it's in German, so you can't read it, but that means today. And I'm opening it. Everything is in German now. So yeah. Okay, and you see how easy it is. If you have these comma-separated values, maybe that's a bit, maybe the hard part to find the data, but you can ask ChatGPT to create actually a data set And if you say it should be a comma separated value file, so it has this extension C for comma separated as value, then ChatGPT will provide you with the table actually, and you can, and then you say to ChatGPT, okay, please give me a download for this file, and then you have the data. That's that easy. That's the easiest way to gather some data to test the CodeUp website. And for maybe you are interested in the temperature in the last months in Paris, you can do it this way. So you ask ChatGPT to give you a comma separated value file for the data you are interested in. Okay. Otherwise, you have to visit a data repository. We will do it in a couple of minutes for the earthquakes as well. And then that's more interesting. So now I have this data and I'm going to this graph, as in the presentation I have shown you before. And you see here are every case, but it's quite untidy. It's quite a mess actually. All the data points are somewhere. So let's take in some order. Let's pull down only the last thing I'm going to do. So the date here, so the measurements are quite equally distributed over this period. But it's now, it only says, okay, we have a lot of measurements during this period of time, but there's no idea how bad the situation of the air quality is. So I have to drag and drop it as well down to the graph. And now you see what I'm interested in. And here you see that's the date. And at the end, near September, at the end of August, you see there's a rise in the aerosol depth. And even if you are interested in more details, if you have some advanced students, let's say in a secondary school, you can do some statistics on this as well. You can calculate it. Maybe I'm showing you this as well. So it's quite easy to calculate some easy data summaries. Maybe let's say the mean value or even more. There's quite a lot of tools outside there. So you have only, to collect some data or to, if I'm going with my mouse over the data I'm interested, they are, now they are highlighted, and you can make, some data summaries from this as well. There are a lot of tools, mean value, and so on and so forth. But that's more the detail. So that maybe that's too much for today. But if you're interested, it's everything there. So you can go there and make this data representations. Okay, that's the main part here for this example. And now I'm going back to my presentation. Let's see. The CodeUp. And I'm back to the live demo, and I'm going down a little bit. Oops. The second example is about earthquakes. So we are going again through these CodeUp examples because it takes some routine, if you only see it once, it's quite hard to replicate actually an example. But now I go a second round and do quite the same for an earthquake. Here we have to gather the data first. This time I'm going to the earthquakes repository. There are more than one, but here in the government, UK, in the US, has a big repository on earthquakes worldwide. So we are going to visit this as well. Collect the data. I'm showing you how you can work with a data repository in a few minutes. So here's just a screenshot actually from the website. And you have to search for the earthquakes you are interested, or the period actually, for the time period. So you have to, as as I have shown you with the fire, you have to put into the date you are interested, and maybe you have even a preference of the magnitude of the earthquakes. Maybe you are interested only in the stronger ones, so 4.5 plus. And if you are interested worldwide, yeah, you have to say it here. So you have actually a search engine in the background. That's the main part here, to search especially the location and the time you are interested. So here it's a second view of the same website. And here you see it, you can download this comma separate values. Actually it's an Excel file. Every Excel file you can save. If you say save as file, save as a comma separated value, every Excel file, Microsoft Excel file, can be converted, let's say, in a comma separated values. There are only data separated by a comma. That's the point here. And it's actually the standard, the golden standard for all data sets in the web. So you are looking always for these comma separated values files. And if you ask ChatGPT to generate a data set, you have to ask for these comma separated values again as well. And now you see, I can put into a starting point in the search engine and an end point for the data I'm interested. That's normal in every data repository to search for the data you are interested. And then you can download it. Maybe we are going to this website in a couple of minutes and check it out. But here I have gathered the data I'm interested, so I'm downloading it for now from my own presentation. So it's done. And now I can go back to CodeUp and import the data. As you see it here in the presentation, but we will do it in real time. The data are there, and this time I have a latitude and longitude. And CodeUp recognized that you have a header with latitude and longitude. So it's obvious that you have spatial data. You don't have to do anything about it, only to write in the header lat and long. Then CodeUp knows you have spatial data, and it will give you an overview, a map actually. If you click here on the right side, and it's always there, this map symbol. If you click here, then you see the distribution of all your data, the earthquakes, in respect to the local data, to the latitude and longitude, to the coordinates. And then you can sort it as well, drag and drop. It's that easy. To organize this data, you can drag and drop it and make order in, let's say, the magnitude, and see, okay, there are only a few strong earthquakes, and here they are highlighted. Yeah, you see where they were, these stronger earthquakes. And even you can, into the map, can drag and drop this magnitude parameter, and then they are sorted in some way, in this case for the magnitude. Okay, let's check out it in real time, make this live demo. Okay, I'm going back to the common online data analysis website. You find it, you know it already, at the resources and tools at the GEO-Academy portal. And now you see it here. And maybe I'm closing the last example. I say I'm leaving, but now I'm back to CodeUp. And you remember, launch CodeUp is the first step. Create new document is the second step. Okay, here. Then the third step is to import the data. Maybe you have gathered it from a data repository, or you have made it for yourself, or you have asked ChatGPT to provide some data in this special format, comma separated values. That's a norm actually. That's for all data. If you are working a lot, if you are in the business of data analysis, you are very familiar with these comma separated files. Okay, I have to import my data. I know it's in the download folder because I have downloaded it before. And here, my data, the earthquake data. I could even show you this file. You see, it's the symbol. It's the Microsoft Excel file. You see it? It's here. It's an Excel, actually. It's not that complicated. It has only the extension is CSV. Normally, it's the Excel is some X. I don't know. It's X something, XLS or something like this. But now it's this comma separated value. But it's not that complicated. It's a comma. It's a Excel sheet. Okay, I'm going to open this, and the data are here. And in this case, I have 100 different data points for the earthquakes, and it would be complicated to realize anything about the data here. I see only the year. Okay, that's fine. I'm scrolling down or forth and back. It's hard to analyze anything here. So you have to visualize them, and that's the main point. So there are all this. I collected the data here in the year 2024, last year. But now it's time to analyze them in a little bit detail. And it's that easy to go back with the mouse, click on this make a map, and it's there. You don't have to say anything because the data have a latitude and longitude. So the program actually knows they must be somewhere in the location. And you see the data are here. And now let's make the same exercise as I have in the presentation. Maybe now I'm doing this graph stuff. So I have all this unordered data points here collected again, but let's make order to drag and drop the magnitude this time here to the graph, and whoops, they are rearranging, and you see, okay, now there are a few stronger earthquakes, and mostly most earthquakes are in this region about, let's say 4.3, something like this. And if I'm interested in this strong earthquakes, I have to go with the mouse over the data set, and automatically I get highlighted this strong earthquake. So I see, okay, this one, that's in here, that's the data point here, and then that's the data point here. So they are quite connected. That's easy to find what data are represented in the map actually. And as well in my presentation, I showed you how you can order the data here in the map as well. You have to drag and drop the magnitude this time on the map, and zoop, now it's here. So you have this magnitude, and if I'm interested in the stronger ones, they are highlighted at the moment. Or if I'm interested in some other data, yeah, that's that easy. You have to click, and then it changes. That's the not that strong earthquakes, and then it's only a few mouse clicks away. It's quite easy to go through the data. Okay, that's CodeUp actually. I never actually saved my work. As you see, it's unsaved, but it's not a matter it's quite as in every Microsoft or in every product, you have to save it here. You can save the file. Okay, so that was CodeUp, 2 examples. The main part is you have some data to analyze. And it's a good idea to begin with a small set of data, let's say 10 or 20 data points you have collected from, let's say you ask ChatGPT to provide some data you are interested in. And if they have a spatial component, so that they have latitude and longitude, you will immediately get this map. Maybe I give you some tips because in the first run, if you are doing it yourself, there will maybe some problems and you are annoyed maybe a little bit. Remember, here, I'm not sure in France actually, but in German, we have the comma. It's if you have, let's say here in the magnitude, here this data point on the magnitude. It reads 4.1. And we write 4.1 in German actually with not with a point. We write it with it's a comma actually. We call it a comma. It's to separate words in a sentence actually. So I have to correct, or sometimes I have to correct the format. So to say, okay, that the program recognized, okay, that's comma separate, that's a value and has a comma in there, 4.1. That's here, it must be a point. That's a very common mistake sometimes happening. I'm not sure about the France convention. If you have it, I think you have it the same as in Austria. We have not a point. If you are writing, let's say 3.3 meters, you make between the 3 and the next 3, you have to write this comma in not as a point. It's more like a comma as in a sentence, yeah. But that's a common mistake. Sometimes that happens. Okay, Lee, that's the code up. And let's jump back to my presentation. There's more best practice examples. I have to move my windows a little bit up and down to get to my presentation. Oops, let's see if I can do it. Yes. It's done. And now we are back to this presentation. The live demo has been done. So let's go to the next stop. Yeah, and here we have, yeah, that's actually an example of the comma separated values. So let's see how it works. And this is from our e-modules, actually. It's a course. They can find it also on the website. At the moment, at the past examples, the only thing you needed was this resource part, resources and tools, and there you find the resources. In my case, it was this firm's website for the fire. It was the MyNASA data website, and for sure, it was the CodeUp website. But if you know these 3 websites, you can do the example for yourself, because for sure you find an e-learning course as well, but it's not necessary as I've shown you. But this time I'm going to show you more about these e-learning self-paced models, as you can find it on the portal website of the GEO-Academy. And I have, yeah, that's, I'm going to click here, I'm back to the portal GEO-Academy, to the course system, and there's a special course. It's the number beneath the map. It's called this way. And I shall give you a short overview, and afterwards we can visit the course system as well. Because otherwise it's quite the same as I'm presenting you today. So the idea is we are going to this course system, and the content for the students, what they have to learn. Actually, normally I start a lesson in school that I have an idea what they should learn. Actually, that's the main part for every teacher. That's for sure, you recognize it as obvious. So in this case, I want my students to learn something about the meaning of decimal places. What's the meaning if there's a number and there are a lot of decimal places? If I'm asked to make calculations, they are giving me all these decimal places. Sometimes it doesn't make sense. Sometimes it makes sense. So they are learning something about decimal places here. And what could you learn on this? Let's say afterwards we have again this live presentation. This time we go to a tool. It's ArcGIS. It's a wonderful tool, and I will show you the position of the Eiffel Tower. You know actually where the Eiffel Tower is, for sure. But with the ArcGIS, it looks like this. And it depends, actually, if you are very precise with the location. I have the location in a table here. So that's the location. If you are very precise and you give me the location at 6 decimal places behind the point, as we have it here in the first row, then you are very precise. That's quite exact. But if you are not that exact, let's say you give me only 1 or 2 decimal places behind the comma or the point here, you're not that accurate. And if you make an appointment with a friend, let's say, let's meet at this and this position, maybe you will miss your friend because you are not that precise. So let's check out this idea. So if you are giving more, if you add more and more precision to the position of the precision. Sorry, precision. So it's how accurate something is to the position. Then you can make it clear. And here in my example, it's visualized. So here you see it, I zoomed in. If I have 3 decimal places after the point, yeah, I'm quite near. I'm at the edge of the Eiffel Tower. You see, you recognize the Eiffel Tower, and here it's on the edge actually. So I'm inside with my friend. If my friend is directly underneath the Eiffel Tower, it's here the perfect position, 6 places after the point, then it's quite correct. But if I only have 3, I'm far away, but inside. But if I give even fewer, maybe it's a screenshot there. I'm not sure. Let's see. No. But I can go back to the ArcGIS, and afterwards we can go directly to the web page, to the course. You see, if you give them none, actually none, only no places behind the point. You say only 2 and 4. At the longitude 2 and 4, you're quite far away. Actually, it's somewhere in France. So if I have 0, let's see here, the lowest here, 2 and, sorry, I was wrong for the latitude. For sure, you have at 48, not 4, 48 latitude. So if I give the coordinates only to this precision, you are far away from the Eiffel Tower. You never will meet your friend, and you will never can see them. It's too far away. So let's visit the website and check it out. And you can also make this in your class. You can make a lesson about the effect of rounding. I did it here. You have in the first example, I only skipped the numbers, but you can do the rounding. It's a nice idea to learn something, how to round the number correctly. It's only a smaller step, and you can, with the tool I will show you, do the measurement, how far away you are from the positions if you skip some places behind the point. So there's a measurement tool as well, and you can measure, let's say, as I have done it here, if I have only 2 places behind the comma, then you are 380 meters away from the Eiffel Tower. That's too much actually to see a person. Okay, let's visit the website in a live demo. That would be interesting. Yeah, it's here. It's a live demo. It says a live demo, but there's no link. So I have to go back because here I have the link. So I'm going back. I hope I have the link. Otherwise, I have to enter the Geo portal and log in into the portal. But here's the link. So I'm going to open this link, as you can find it in the e-learning modules. And now it opens. It takes some minutes. It's ArcGIS, and it's not, yeah. So you have all this data, and now it opens in a couple of seconds. Yeah, and we have an overview of Paris. And if I zoom in, now it should work. I will see what I said before. So if I moved you a little bit around, so now you see, if you have only one decimal place, you're somewhere here outside of Paris. It's not that far. If you are looking for a friend, it's too far away. But if I'm going nearer and nearer, let's see, let's say more focused. This is if I skipped the decimal places. I have not done any rounding. In the second example, I had done a rounding. But now you see it must be somewhere here. And if I go even further, nearer to the, as I've done it in my presentation, you see, okay, there's a difference in the coordinates. And that's easy to be done in ArcGIS, in this example, as you see it in my presentation at the moment. So now I'm quite below the Eiffel Tower. And I show you the measurement tool here as well. So if I'm interested in measuring out something, the problem is only that the window is on the below a second window for the Teams presentation. So I have to move you away. And now I do this measurement. I click on measurement. And let's say I want to show you that the 3 decimal places and click here. So, and go, oops, sorry, I have to go here. And now it's a different unit system, it's feet, so I have to change this as well. That's the Imperial UK measurement, it's 160 feet. I'm not familiar with this. I am familiar with the meter, so I have to change this as well. But for this, I have again to move you away from my screen. So now I'm doing it again. I have to measure to change the measurement. You can also measure an area here as well. It's that easy. But let's see where to change the unit. Let's do it again. So measurement again. So map tools, measurement. So, and now first point and that's the unit. So I'm going to change the units to metric. So now it's meters, and now it's fine. So, okay, it is 45 meter away, 45 around. So from the middle. So if you're going to the edge here, it's something like 100 and something. But you get the idea. It's a nice tool to think about, or a nice way actually to think about the decimal places. What's the meaning about a decimal place? Okay, that's it for ArcGIS and the e-models. So sorry, I have to leave it on this side and go back to my presentations. Maybe we can talk about afterwards about these examples if we're interested in some details. But for the moment, I really showed some different stuff. Let's see, I have to move my windows again a little bit out of the way to see something for myself. Okay, that was the Eiffel Tower I presented to you. And the precision and ArcGIS, and it's in an e-learning module. So, okay, the measurement, the difference, yeah, I've done it. And then I'm going down, wait a moment, because the Windows doesn't move as I wanted. Live demo we have done. And the next tool, and it's actually the last stop for our tour. It's the Gap Minder. It's a very interesting tool as well. So let's have an overview as again, it's the first run, I'm going to an overview as I've done it in the past with the other tools. But here again, I show you something, and then we have a live demo, and I go to the website, and you will find again this description of this e-learning model about the Gapminder in our e-learning models. It's called the Gap and the Mind. Okay, let's see. You find the direct link here. Portal, GEO-Academy, courses, the Gap and the Mind. So it's from there. My screenshots are from there. And in this case, it's more about the screen and environmental stuff we have implemented in the GEO-Academy. Environmental education, green skills, education for sustainable development. It's more about this I'm focusing on. For sure, you can focus on different ideas with the Gapminder, but in my presentation, I'm focusing on these topics. So if you open the Gapminder, it's open with this website, and it starts with, you are probably wrong about some topics. Actually, that's, yeah, the plastic in oceans or something like global warming, but that's not the main part. The main point, the interesting part is here in the resources. It's called resources as in our website. So we go to the resources, and then you find the tool, and the tool looks a little bit different. So that's the website, the Gapminder. You find it in the e-learning, how it is named, where's the website, and so. And again, we have to visualize the data. And how does it look here with Gapminder? You have different ways to visualize data with the help of Gapminders. And today I'm focusing on these maps. Oh, maybe I don't remember. Maybe I show you as well the trend lines as well. I'm not sure what I have done in this presentation. Let's see. Yeah, the first is about these bubble maps. It's called bubble maps. Yeah, it's a map and bubbles. That's what I'm showing you. And I guess I show you even these trend lines. Yeah, here. It's about the water withdrawal from some areas or cities, actually, or regions, actually, more regions, yeah, per person. I show you how easy it is to handle such a website. Okay. Yeah, that's what I'm showing you, the water withdrawal for different countries. So you can check out for France as well. It's not here. It's Russia, it's China, US, Nigeria. But if you are interested in Austria, we will check. Maybe we check Austria and France. That would be nice to see if what's about the water withdrawal. I don't know, actually. I didn't check it before I started this presentation. So hopefully it's not embarrassing. So let's see. Okay, good. The last tour starts here. It's again, it's a lot of clicking and stuff like that. So you can handle it. It's not that complicated. And here it is, the live demo. I should do a live demo. So let's start a live demo, the last live demo. And I'm going back to my web browser, this time not ArcGIS, with this precision topic. I'm going to Gapminder. I have it on my mind, so I don't, yeah, it starts with this website. That's normal. And I have again to move you away a little bit to get to these resources, these resource windows. And here in the middle, I have this maps. And here it is, the starting point. And maybe you are interested, let's say, in something different. Let's say, yeah, now what you see is quite maybe a little bit complicated. So let's say we check out some different data. So that's the domestic it's the domestic per capita. You see this here, the gross domestic product per person. That's how rich a country is actually. That's not that in my interest today, and the life expectancy on the other side. So we have, if it starts with some data, because I didn't say anything. So I have to change what it shows us. Let's check out some different data, this map. And this time I have the population, but you can change it. If I'm clicking here, I can change what it shows me. There's a lot of economic data, education, energy data. There are a lot of data sets already there. But to show you how it works, it would be easy to go with this population data, because often we have a timeline as well. So that's the population worldwide as it is at the moment, not at the moment, at 20, because there are no data for data above 2023 exactly. So, but in the past, we have some good data. So if I'm going down to the timeline and start this timeline, it goes step by step through the data. Have a view on Africa here, and as well as Asia. So if I go here, have a look how it will develop, and Europe for sure, and USA as well. So let's start. So it starts in 18, as you see, it's like a movie, and the bubbles are growing because the population is growing. If the bubble is bigger, there are more people there in this country. It's the population of the whole country, not of a city, it's the whole country. And you see how big the distribution is in Europe, already in the 1900s. But now it's a little bit changing. The picture is changing in the Asia region. It's growing very fast. Now and there's no movement actually in Europe. It's quite the same. It stays constant, what you would say. So you have this data, and if you are interested in some special country, you have on this right side, I have to move you again. You can highlight some areas. Let's say France. Let's check France. So yeah, now we have France. That's the highlight of France, and I can compare it with another. I add some other country, and then I'm going. You see in France through it's the same now. The timeline only for France. And here you see the population as it runs through. It says it's nearly 40 millions now, and it's growing. Oh yeah. And now, yeah, there was the World War first, and the Second World War, so there was a little drop in between. Okay. That's an easy way to visualize data with the Gapminder, but I show you the second part, this trend line, as it is in my presentation here, the trend lines, and I'm showing you this water withdrawal, and let's make a comparison between Austria and France. So at the moment, I have again this GDP, this gross domestic product. If I'm going through this question mark, I get an explanation what is shown, and this is the time, obvious, and how rich a country is. I'm not that interested in this, so I have to change it, and then I show you how to change it. But before I'm going to change, I have to move again something. Okay, and now I only click on this header, and then I have some ideas, and let's say it's about water withdrawal, I guess, but I have only to guess. You see how many data are there. It's amazing again. So, but I guess it's about environment. So I check environment. I guess it's not there because it should. No, it's there. It's water for sure. And let's say what's yeah, here it's the water withdrawal per person. And you have an explanation as well here. So I'm interested in this data set. I click on it, and now it is here. Because there are no data for Russia before 1992, you don't see it. It starts here, 1992, and it's the same for the USA. But for other countries, we have the data, so it's there for China. But let's see if we find the data for France and Austria and compare them and bring them to the graph. And yes, it's quite easy. I have only to move you a little bit at the other side because this time I need this part of my screen. Okay, so add France. France, yeah, I'm at France. Boop. Now it's here. It's a little bit above Russia and Austria as well. But because there are no data, so you see, it's only a data point because only in the year 2002, on this website at least, they haven't any to present any data. Oh, in Austria. That was not Australia, it's Austria. A little bit below, but quite in this region. But we have data. Okay, so, oh, that's a bad news. Actually, the water withdrawal per person is rising, quite not that nice for environmental reasons, actually. So we are using more and more water as the time goes by. It's bad news for Austria. Yeah, it is. It is. Okay. So let's, yeah, it's the same. I can play the timeline, and as we have data, they are shown. Okay, that's a quite a good tool, this Gapminder. You can find it, and you see how rich actually the data are. You can have this CO2 emission, carbon dioxide emission per person, actually, the child mortality, daily income would also be interesting to check daily income or life expectancy. I guess the life expectancy for France and Austria. Let's check out life expectancy. Sorry, I'm interested in this at the moment. Ooh, let's see. Oh, it's a crazy data here. Life expectancy. Let's see. So what's this here? Austria and France quite on the top. Quite the same, yeah. It's even higher. Yeah. That's probably the baguette, I guess. The baguette, that's the makes the difference. Or maybe it's the good wine. But yeah, it's higher. Okay, you see this life expectancy for France and Austria. It's quite the same. And you see the world wars here, this big drop. It's very disturbing, yeah. Okay, that's it. At least here in the live presentation mode. Let's check, go back to my presentation here. Oh, I have only to say thank you. And if you have question or you want to add something in a special tool, let's say Gapmind or CodeUp or ArcGIS, this I have the time to show you in some detail something about the thing I have presented to you. I think it's very interesting, the tools we have on this portal. Maybe at the final, it's a good stop point actually for this tour to go to the portal. Actually, I have missed this because it's for me. I'm very familiar with it, so I didn't think about it to show you the portal in real time or in real on the real website. So now I have to move you again. And here you see you can change the language. Then I can read anything. So let's go to French. So wow. But I remember what it is, what it means. So it's easy. So let's check out if I find everything in French. That would be hard for me. There are the tools. And I recognize, actually, sorry, it's a little bit cheating because I see the pictures. Oh, that's a great tool, the Zoom Terre. Oh, I like it. It's super. Oh, everything actually is great. I like everything. Though this is the firm's website I showed you in my presentation. CodeUp is here. I didn't show it. Sorry, but it's wonderful. The Global Forest Watch, a wonderful tool as well. And so you see a lot of tools. I can't go through every tool, but you can sort it through. You see the primary, yeah, école primaire inférieure. Sorry for my French. And then I go to this model, the Tours les Corses, Tours les Forces, I would name it, Tours les Forces. And these are all them models, but if I'm clicking only here, you see an overview. Yeah, you see it? And mostly I've done this Earth observation stuff, the satellite data and how to work with data. I have shown you how to import data files. I gave you some ideas how to you create on the scratch on a very small time scale data for yourself. You ask only ChatGPT to create a data set you are interested. Let's say, create me a data set and give me a comma separated value file. Then you bring it to CodeUp and you can work yeah, for yourself. That's important that you do the stuff for yourself. Then you get trained. And for the students, we have also on this website this evaluation. So we have some ideas how to evaluate to see if my students could follow the stuff we have presented here in these e-learning models. So that's this wonderful GEO-Academy portal. It's so rich. It's amazing, actually. Sometimes I wonder. Yeah, really. Yeah. Yeah, that's it. Maybe I closed this sharing and we are back together. And if you have some question, please ask me and I show you the details you are interested in.
Copernicus browser, we will show more in the upcoming trainings. It's teacher friendly, let's say, and you can have directly exemplary cases for your students for different applications. For example, agriculture, monitoring Earth from space, change detection. If we select, let's say, for example, floods.
Yeah.
And we press here in Greece, in Thessaly a few years ago, it's loading. It takes some time. You may see the flooded areas here in Thessaly 2 years ago. You can zoom in, zoom out. You can export here on JPEG. You may change and load agricultural stuff, let's say. It will take a bit to load, but it's quite easy, quite straightforward. Of course, you can start searching on different satellite missions, different dates, but it's really, really easy and straightforward. So here, how we map agricultural areas from space and many, many more. As a teaser, just as a